evaluate a limit. Let's move on now. So evaluating limits graphically. So to do this, you would look at a graph and observe what the function is approaching sorry for my terrible A there, is approaching as it gets closer to some x value. So you basically look at a graph and observe what the function is getting really close to. Again, this is just getting close to as it approaches some x value. Okay, that's basically the end. Now, important note that we need to keep in mind: for a limit to exist, it must approach the same y value from the left and the right. So in other words, if you have a function like this and you're calculating the limit, say over here, it must approach the same thing from both sides or the limit would not exist. And you'll see what I mean by this in just a minute when we go over some examples. Okay, so here we go. These are called the left hand and right hand limits. Okay, so let's go ahead and just talk about how we'd annotate these really quickly. So to annotate the left hand limit, it's basically this: the lim x approaches c, but with a little minus sign there, of f of x. So just don't forget the minus sign. This means the limit as x approaches c from the left. Now, what about this one? This would be just c from the right of f of x. Again, just that plus sign there. Okay, the limit is f of x as x approaches c from the right. Okay, so this is how we would annotate this, and we must always look at these two when we are computing limits. Okay, all right, let's move on. So here is a function. Okay, and just a quick example that I want to do for you. So I'm going to ask you to calculate the following. Calculate the limit as x approaches 1 of f of x. So if you want to try this out for yourself, go ahead and pause the video now, and if you want to just see what the answer is, just keep going. Okay, so let's go ahead and calculate what the answer is. To do this, I'm going to break this up into two parts. Okay, I'm going to find my left hand limit and my right hand limit. Okay, I'm going to find both of those. I'm not sure, I'm sorry if you can't see it properly, but there's my minus and there's my plus. I'm going to find them both just from the graph. So where's 1? So 1 is up here, so it goes, sorry, my drawing skills are bad, goes over there. So we're going to just trace the function and see what it's getting close to as we get closer and closer to 1. So from the left, it seems to be getting closer and closer to 1 as f of x approaches 1. As x approaches 1, f of x is getting closer and closer to 1. So the answer to this would just be 1. Let's try from the right. Okay, let's go, keep going down, and ultimately we would reach 1 from the right as well. So this would also equal 1. So we'd say that the two are equal to each other. Okay, they are equal to each other, so therefore we can say that the answer to this is just 1. Capiche? Sound good? Okay, let's move on. One more example in this. So I'm gonna ask you to calculate over here the limit as x approaches 0 of f of x. Again, try this on your own if you want, but if not, we'll just go ahead together and solve this together. Okay, let's go ahead and talk about this. So again, we're just going to do the same thing here. We're going to break it up into left hand and right hand limits. X approaches 0 from the left of f of x, and the limit as x approaches 0 from the right of f of x. Always break it up into these two components. Okay, so let's go ahead and see what happens as it goes approaches 0 from the left. So we can see it's going like this, and then suddenly it's going up and 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 up, and it doesn't seem to be really approaching any one value as we get closer and closer to 0. It's just going up forever and ever and ever. So we'd say that this approaches infinity. Again, infinity is not a number, it's a concept, so technically this does not exist, but to be specific, we want to say that it's approaching infinity. Okay, just so you know. And whoopsies. And now let's look at it from the left. As we get closer and closer to 0, we keep going down. Sorry, my line is so bad, but we keep going down here. We're going down forever and ever and ever. So this could be said to be equal negative infinity. Again, this means it does not exist, but we need to specifically mention that it's going to infinity, just so we can be as specific as possible. Now let me ask you this: do the left and right hand limits equal each other? Does negative infinity equal positive infinity? No, does not, right? So therefore, these two limits do not equal each other, and therefore the limit does not exist. Or D, you can just say D and E. The limit as f of x approaches 0 does not exist. Again, it's important to keep this in mind. And just as a reminder, for a limit to exist, the function must approach the same y value from the left and the right. Okay, just a reminder, it must approach the same y value from the left and the right. If it does not, then you get something like this. It doesn't make sense. Just intuitively speaking, what would be the limit of this? Like, from one side it's going up and from the other side it's going down, so you can't give me a definitive answer. It's like two answers in one, and therefore it doesn't make sense. Okay, so let's move on. So now let's talk about evaluating limits numerically. So this is very similar to evaluating limits graphically, except that you look at a table of values instead of the graph. Okay, so instead of a graph like this, you just look at a table of you'd be given a table of values for x and f of x, and then you just use these values to determine what the function appears to be approaching. This is probably the easiest of the three, so I'm not going to spend a whole lot of time on it. Okay, and this is also what we're going to end today's video on. Let's move on. So this is the function that I pulled off, the f of x equals x squared. So now I'm going to ask you the limit as x approaches 0 of f of x. Go ahead and try that on your own, and then if you get stuck, just go ahead and play the video. Okay, let's go ahead and work through this. So again, as always, we break it up into left hand and right hand limits. X approaches 0 from the left, the limit x approaches 0 from the right, f of x and f of x. Okay, so let's take a look at what's happening here. So f of 1 is 1, f of 0.9 is 0.81, 0.5 is 0.25, 0.2 is 0.4, 0.1 is 0.01. So as you can see, the values are getting smaller and smaller and smaller, and it's getting closer and closer to what appears to be 0. So if you put even smaller values in here, like 0.001 squared, you'd see that you get a really, really small number here. So therefore, you can just say that this equals 0. Okay, let's look at it from, that would be from the, whoops, my bad. This would be from the right. Let's look at it from the left now. So negative 0.5 squared is just 0.25, negative 0.2 squared is 0.4, negative 0.1 squared is 0.01. So again, the closer we get to 0, like if we could plug in negative 0.00001, we're still gonna get something that's really, really small and really close to 0. So again, that would just be equal to 0. Okay, so again, do our left hand and right hand limits agree, or do they equal each other? They sure do. So therefore, we can say that the limit exists and that it equals 0. Okay, So I want you to, so that's our answer, but I want you to notice one thing. What did I not give you here that I gave you with the graph problem? I didn't give you what f of 0 is, right? I did not give you in this table what f of 0 is. So that brings up a little bit an important point that I want to talk about. So as a reminder, we do not care what happens at the exact x value, only what happens as we get really close to it. So again, here, do we care what happens at f of 0? No, we do not care what happens at f of 0. We only care what happens as we get really, really close to it. Okay? So we care what happens at 0.000000001. We care what happens at negative 0.0000001. We do not care what happens at x equals 0. Okay? That's the whole concept of a limit. We get really close, but do not equal that value. It is handy to have that value, as you will see in later videos, but it does not pertain to what we are doing. Okay, so that's the end of this video. Thank you for watching. I hope it was helpful. Have a good day.